Hi everyone, Krishna this side. So in this video, I'll be covering this whatever the solution that I have derived in the morning session. That is something what I want to explain this particular video because there were a few doubts into the code and those I haven't cleared it in the morning session because of having some issues. So yes, we'll again go through the code and we'll see like how we actually write the code. The formula that we have generated that should be clear to all of us till now. So what we can do is we basically walk through the code and we are actually getting all the different results from the formulas and we are multiplying it and we are returning it by at the end. Okay. So the first thing is like we actually need the factorials of those numbers, okay? Because NCR is something what we are trying to figure out. So n is basically n minus 1, r is basically k. These values we have already with us. So to get the factorial of a number, we are simply the zeroth factorial is basically 1, and we are storing these values in the form of arrays. So whatever the n value we have till there, we are going and we are storing these values in this factorial array. And it is pretty much easy to get the factorial of any number. So factorial of 2 is basically 2 factorial 2 into 1. So previous value whatever we actually got, okay? Factorial of 1 is like factorial of 0 into current value, okay, 1. So that's how we are deriving it. So we will keep on getting the factorials of all the numbers, and this n factorials also we can get it, which we will be storing it into this factorials array. Okay, the moment we do that, the next step is like we are actually looking for the inverse of factorial of numbers. Okay, so n's factorial is n minus 1's factorial. We can get it from this one. Okay, that is something what we are multiplying. So this is the long variable that I have created where I actually getting the factorial of n minus 1. Okay, that we can get it from here. Now the point is like 1 by r factorial, sorry, 1 by k factorial is also there. Okay, whatever the formula that we have, let us look into this particular image. So this was the formula, right? NCR, if it is there, so n factorial is something what we can get it from the factorial. But 1 by r factorial, this value how we can get it, right? So that is the first question, and second is like 1 by n minus r factorial, that is also we have to get it. Okay, so these are like basically inverse of factorials. These values are something what we actually trying to look at. Okay, the point now here is, so all these values are actually big. Okay, whatever the numbers that we are trying to derive, these values are pretty much big, and always it is preferred to get these type of values into the formation of modulos. Okay, that will be there in different all different kind of questions. Okay, so with the help of this one, we can actually utilize this Fermat's theorem. Okay, so okay, now 1 by r factorial is something what I actually want to get it. Okay, or 1 by n minus r's factorial also I actually want to get it. So before going there, we will let us try looking into this Fermat's little theorem, what it basically says. So any inverse of number modulo mod, if this is something what we actually want to get it. Okay, so here if this value is something what we want to get, so this is basically equals to this a to the power of mod minus 2 again modulo mod. Okay, so this whatever the mod value that we are looking at, this should be prime number. Okay, so yes, it was actually derived from its original formula, and we can get this one. So to get it, any inverse numbers factorial, okay, any inverse numbers value which is actually modulo with mod, the mod should be prime number. We have to apply this formula. Okay, so let us try to understand this, decode this one. Okay, so let us say that 1 by a. Okay, in our case 1 by r factorial and 1 by n minus r factorial answer is something what we actually trying to get. So here this r or n minus r's factorial is, let us suppose it is actually a. So 1 by a factorial, 1 by a modulo mod equals to x. We can get any answer. Okay, x is the answer that we are currently thinking of. Okay, let us say that a value is actually equals to 3 and the mod value is actually equals to 5. So whatever the value that we are getting this mod value, it should be prime. And the value that we are having this 10 to the power of 9 plus 7 is actually a prime number. Okay, so yes, we can apply this formula. Okay, if any inverse of number is something what we have and we want to get its modulo. Okay, so we can use this formula. So how we can apply this one? Okay, see, let us first understand this particular theorem, how it is derived. So a is, let us suppose 3 is the value that we have, or the mod value is 5. So 1 by 3's modulo 5 is basically how we can represent. We can apply this formula. Okay, so 3 to the power of mod value is basically 5 in our case for this particular example. 5 minus 2 again modulo 5, whatever the mod value that we have. Okay, this way we can represent. So 3 power 3 modulo 5. it is basically 27 modulo 5 is the value that we get when we derive this one. The remainder that we can get is 2. Okay, we are basically looking for the reminders in all these modulo operators. Okay, so that is pretty much clear for all of us. That should be having idea previously before trying to solve this all the modulo type of questions. Okay, so yes, 27 modulo 5 is basically equals to 2. Now we got x value, okay, with this formula, but we can re-verify it. Okay, so 1 by a modulo mod is equals to x. That is this thing that we have. So in this particular case, what we can do is 1 modulo mod equals to x into a. That we can do this, whatever the a below here, we can pass there in that side, and this can be converted into 1 equals to x into a modulo mod. Okay, this is the derivation of whatever the form this value that we are trying to get. We can decode it till this way. Okay, so x is something what we have to figure out, because a is something what we have, mod is something what also we have. So now if we got x, okay, x with the help of this formula we got the x. Okay, and if we place it right over here, 3 into 6 modulo 5 is basically equals to 1, and that is something what we are actually looking at. The value should be equals to 1. Okay, with the help of this same formula, when we decode it, the answer is basically we are getting 1. Okay, so both values are matching. That means like we can apply this formula at any places. Just we have to make sure that this whatever the mod value that we are considering, it should be a prime number. Okay, so these things are clear for us, all of us. Now we can apply this same formula in our case as well. Okay, once we got this formula, we actually saw with example as well, like how we can verify this if it is working correct or not. We check that when we whatever the value that we have, we can move that in this way, and this is the derived formula that we can get. Here x value is something what we have to figure out. We can try out different values placing there and see if it is getting equals to 1. Okay, so that way also we can do it, but it is actually basically again looping till 1 to n if n is the answer that we are looking out. Okay, for x value, but with the help of this formula we can easily get it in log of n time. Okay, so yes, this 3 to the power of 5 minus 2, this whatever the value that we have, we can actually solve this with the help of logarithmic time complexity. Okay, so whatever the value that we have to the power base to the power of whatever the value that we have, if we want to solve that one, we can solve it actually with the help of log of n time. Okay, so we got this formula, and we are basically looking for the module of that particular whatever the answer that we can get it, and that is something what we are we can able to figure out. Now the question is like we actually are looking for 1 divided by r factorial. So 1 divided by r factorial can be equals to 1 by a factorial. So whatever the r value that we have, let us consider it as a, and mod value is basically we already have 10 to the power of 9 plus 7. So we can again use this particular formula that we actually saw right over here. So a to the power of mod minus 2, again modulo mod. Okay, that is the formula that we can apply right over here. So it is like a's value is something what we can already get it from this one. Okay, from this factorials of number, we already saw all the different factorials of numbers, that is we figured out with this one. Okay, so we actually stored them. So yes, we can utilize those all the values that we already figured out, and what we can do is whatever the force r's factorial. Okay, if let us suppose force factorial is something what we are trying to figure out. Force factorial value is something what a value, and mod value is 10 to the power of 9 plus 7, and minus 2 is something what we have to apply, because that is the formula that we have, right? Again modulo mod. So this is the answer that we actually trying to look. Okay, that's why I have written right over here in this line number. So this mod power is actually our function. Okay, to get a to the power of, let us suppose x is something what we are actually trying to figure out. So with the help of log and time, we can actually derive that one. Okay, that is the mod of power function basically doing. And this factorial of number, see, now what we can do is basically whatever the last factorial of number that we derived from this one. Okay, first we can get the answer for that one. The moment we get the answer for that particular function, we can easily solve the whatever the previous indices that we have with the help of some calculation. Okay, that is the calculation that I am doing right over in this for loop, that I can explain you guys. But the thing is, we are actually putting this last indices. Okay, n minus 1, whatever the factor of n minus 1 that we got, that is something what I am placing right over here. Okay, because once we get the last indices of the factorial, we can easily get the lower values factorials also, inverse factorials also, very easily. Okay, and mod minus 2 is something what the mod value is actually 10 to the power of 9 plus 7 is the value that we have, right? That is something what I am getting right over here, minus 2, because of the formula that we are doing it, right? So whatever the formula that we saw here, correct, if we look into this one, a to the power of mod minus 2, the a value is basically whatever we got it, the factorials value, that is something what I have kept right over here, and mod minus 2 is the value that I am passing to get a to the power of whatever the mod minus 2 value that we are actually looking for. Okay, so this particular function can give me inverse of 1 by n minus 1's factorial, because n minus 1's factorial value is actually I am looking for. Okay, and we are actually applying this modulo every time. Okay, whenever we are trying to get any values, we are actually applying these values, so that way we can get this answer easily with the help of this particular theorem. Okay, why we are applying this theorem? Because we are actually putting this mod every single place whenever we are trying to get the answers. Okay, so we can apply this formula in our case. Okay, so wherever we see that NCR or NPR, these type of questions we get, arithmetic questions, so we can apply this type of formula. Okay, to get the answer quickly in log of n times. Okay, so yes, that way we can get this mod power function. I can explain you guys in this particular video as well. So let us see that now this for loop is how it is working. Okay, now I got inverse of 1 divided by n minus 1's factorial answer. Okay, n divided by 1 minus n's factorial answer. Okay, this answer is something what I actually got it from this above statement. Let me put this in comments. Okay, okay, this is something what I actually figured out from here. This mod power function I'll explain you guys, wait for that one. But yes, this is we figured out with the help of the Fermat's theorem. This is the mod that we have, right? So for this one we got the answer. Okay, now n minus 1's inverse, whatever the answer that we get, inverse factorial, that is the answer that we got from this one. Okay, the moment we get this one, now just tell me that, so if we are actually looking for let us suppose n is actually 4, 4 factorial answer is something what inverse of 4 factorial is something what we got. Okay, so it was like 1 divided by 4, let us suppose n is basically 5. Okay, 5 factorial answer is something what we are looking for. Okay, 5 minus 1's factorial answer, we got it. Okay, this answer is something what we got. Now just tell me, if I want inverse of 4 factorial answer. Okay, inverse of 4 factorial answer, with the help of this previous whatever the answer that I got, I can utilize it and I can easily get the answer. How I can get it? So whatever the answer, let us suppose its answer is basically x is the answer that I got. Okay, now in this case what I can do is, whatever the previous value, this the answer that we were trying to get, what I can do, I can multiply it with 5. So how it happens? 5 into 1 divided by 5 minus 1 factorial. Okay, 5 minus 1 is factorial, and again we can put mod. Okay, whatever the answer that we got, this answer we can multiply it with itself's value. So what it basically does? Okay, sorry, it will be n. Okay, correct, it is actually n, whatever the n value that we have. Okay, so n I plus 1, so whatever the value that we are currently at index, that is something what we actually are putting there. Okay, so whatever the previous value that we have, okay, it should be 6. When we are trying to get 4's factorial, 5's factorial, it should be 6 minus 1. Okay, the because that is something what we are trying to figure out. N minus 1 is something what we are getting it. Okay, 5 factorial answer, inverse of 5 factorial answer is something what we got from this one. So now inverse of 4 factorial answer, if we want to get, so previously whatever the answer that we have, if we multiply it with this I plus 1, currently the index is like n minus 1's index we are at, n minus 1's index value is something what we got, n minus 2's index we are looking, then n minus 3's index till n basically I is equals to 0, till that index we are actually trying to get the answers. Okay, now in this case how it happens? So 5 divided by 5 factorial. Okay, that is the answer that we are looking at, right? 5 factorial. And this previously already we got this answer, whatever the previous answer that we have, this answer is something what we already got. So now what happens is 5 divided by 5 into 4 factorial is something we can do. Okay, 4 factorial is something we can do, 4 factorials we can get. Okay, these 5 and 5 both can get cancelled, so what remains? 1 divided by 4 factorial is something what we will be having with us. Okay, so this is the answer that we are looking at. Inverse of 4 factorial is the answer that we are looking at for index n minus 2. Then n minus 3 is the index, that is going to be 3. For third index, whatever the previous answer that we got, Okay, if we multiply it with that one, so 4 will get cancel, 1 by third, 3 factors inverse answer is something what we can get it. So that is the formula that we are applying, keep on applying right over here. So n minus 2, the index that we are having right over here is basically n minus 1's index is something what we got. So n is actually the range, so we cannot go out of bound from this array, right? So we are actually storing all the factorial till n, correct? Till n is the factorial answer we are actually looking at, n minus 1's factorial answer. Okay, from n minus 1's factorial answer only we are going, keep on going backside, because see, ultimately this formula is basically, we are, whatever the formula that we are applying is n minus 1's, till there only we are applying it. So we actually are not required to bother about n's factorial answer. Okay, so we are actually going till n minus 1. So this first for loop was also going till 1 to n minus 1. Now n minus 1's inverse factorial we got, n minus 2's inverse factorial we can get it by multiplying whatever the previous answer that we got from this inverse of factorial. We do not require to keep on calculating the inverse factorial of n minus 2 or inverse factorial of n minus 3 till inverse factorial of 0. Okay, we can, whatever the previous answer that we got, we can easily multiply it with, so that whatever the value that we have, top value, inverse of 5 factorial into 5, if we do, it will be the inverse of 1 by 4 factorial. The answer that is something what we can get it. So we can keep on getting these values, and we can keep on filling into this inverse of factorials array, so that now we are actually having inverse of all the different factorials answer till n minus 1. Okay, from 1 to n minus 1, 0 also I have included, so it doesn't matter if we are including or not. Okay, but yes, zero's inverse factorial also we can sometimes get it right. 1 minus 1 is going to be 0, so it doesn't matter, we are getting its value as well. Okay, so yes, that is something what this for loop basically does. All the inverse factorials answer we get it. Now in this inverse factorial, definitely this k will be available, and we can go into that particular kth index, and we can get the inverse factorial of k's value. Okay, from this inverse factorial, and previously factorial of n minus 1 into inverse factorial of k. Inverse factorial of k is like 1 by k factorial. That is something what this particular for loop basically doing. And inverse factorial of whatever the answer previously we got, we are keep on doing this mod operation, because sometimes the answer may get out of bound. So yes, we have to keep on applying this modulo mod. Okay, now again we are getting inverse factorial of n minus 1 minus k, because that was the formula, right? So n minus 1 factorial divided k factorial into n minus 1 minus k factorial. So this value will be also available in this inverse factorial. So that is something what we derived, and we keep on getting this value. So nck is something what we figured out. Now power, so n minus 1 possibilities are there for where we want to have whichever the indexes that are left out in between or at the end. For those indices, m minus 1 possibilities are there, and those, how many those indices are there, n minus 1 minus case, these are all things we already saw in the morning session. So yes, mod power is something what we actually figured out. That means like n minus 1 to the power of n minus 1 minus case. This answer same, it is like this also, and this, both the functions are doing the same, like we actually put it on in the function, and we are trying to get the answer. So whatever the power of any number, if we want to get it in log of n time, logarithm of n time, because normally if let us suppose 10 to the power of 5 is something what we have. Okay, let us look into the image as well. I have already got that one. So let us suppose 10 to the power of 5 is something what we want to derive. So for loop we can run till n time, correct? From uh, of, like it will be go till first till 5. A for loop we can run it, and we can keep on multiplying whatever the base value that we have. 10 is something what, let us suppose we have, we can keep on multiplying till 5 times. Okay, this is like basically it will be taking n basically we go of n times it will take when we try to solve this particular one. But in our case, see, if we do the same operation for this one, like whatever the factorial of this value that we have, and mod of n minus 2, if we keep on doing the same operation, it will be really heavy and costlier as well for us. So what we can do is, we basically whatever this answer that we can get it, we can basically use with the help of this particular functionality to solve this one in log of n time. We can apply this particular one. Okay, so how this basically works, let us suppose whatever the base value that we put. Okay, in this case factorial of whatever the n minus 1 factorial value that we passed right over here for the base, to the power of whatever the exponential value that we have, mod minus 2. It is like 10 to the power of 9 plus 7 minus 2 is the value that we are actually having. That is something what the exponential power that we have. So we, what we will do, this base value whatever we have, we first try to see if it is going out of bound. If not, if it is going, so we will do mod, and we get the base value. Now the moment we get the base value, what we will do is this exponential, what we can do is basically it should be greater than 0. First while loop is something what we are running it. Inside the while loop, we will check if this exponential, whatever the exponential value that we have, if it is actually even or odd. Okay, that is something what we will check. If it is odd value, so what we can check, see this particular whatever this and operation that we are doing with one, these things should be clear for us. Okay, see whatever the exponential value that we have, if we want to check it if it is even or odd, okay, we can easily apply modulo of 2 as well. Okay, whatever the value that we have, we can apply modulo of 2 as well, or we can do and with 1. Okay, because any value that should be odd, the first binary value, okay, first from the right side, okay, first value should be 1. So any value, let us suppose if this is the value that we have in the binary representation, okay, this is the value we have, which will be basically odd as well. So if we do 1 with and with 1, so definitely this answer is basically equals to 1, because all the rest values will be comparing and with 0, and those will get cancelled, but the 0th index is actually 1. So this is basically giving us 1. Or else we can, what we can do is we can put modulo of 2 as well, and we can check if it is equals to 0 or not. If it is not equals to 0, that means it is odd. So this way, either of the way we can apply, just to need to check that whether this exponential value is even or odd. So if it is odd, what we can do is we will create a result. In the result, what we can do is whatever the base value that we have, that is something what we will multiply. And yes, we have to apply this mod every time whenever we are doing some calculations. And next thing is like whatever the base value that we have, we will update it. Okay, previously it was 10, let us suppose base value is 10. So what we can do, 10 into 10, that is going to be 100. So base value got updated to 100. And we will, what we can do is this exponential value, we will shift its first bit, whatever the first bit that we have, we will shift it. Left shift is operation something what we are doing it. So this way what happens is whatever the value that we have, exponential value, we are simply dividing it with 2. Okay, so this again, this operation is basically division operation. So exponential value, we are simply dividing it with 2. Exponential divided by 2. Okay, if it was 5, 5 divided by 2 is basically it is going to be 2. Okay, that way we are just decrementing its value. Now how this operation basically works, we keep on doing until the exponential value is actually less than 0 or equals to 0. So this particular while loop keep on going and we keep on getting the results. But how this is basically working, that is something what, let me help you with this example. Okay, let us suppose 10 is the base value and exponential value is 5. So we, when we multiply this 10 times, it is going to be obviously 5 0 that will get added in front of 1. But this can be represented as 10 to the power of 5 divided by 2 to the power of 2. Okay, if this number is odd, okay, whatever the number that we have, exponential number, if it is odd, what we can do, whatever the result so far we got, we will simply multiply it with 10. So that is the operation that we have done. Okay, if it was not odd number, we wouldn't have gone into this condition, but the number was odd. So what we can do is whatever the value that we got at the top, this 10 value, which I bring outside. Okay, this way also we can represent same thing. Okay, so it is basically 10 to the power of 10 into 10 to the power of 2 to the power of 2. This way we can represent this one. So result is basically updated to 10 into 1. Basically the previously the result was 1. Okay, result was 1. Now result got updated to 10, because this particular, whatever the 10 to the power of 2 to the power of 2, we can keep on multiplying. So now this base value will get updated to 100. Okay, because we are multiplying this base value. Previously base value was 10. Now the base value will be getting updated because we are multiplying 2 times, so that whatever the inside this 10 to the power of 2 is there, we will derive itself and we will update into the base value. Now base value got updated, and the exponential value will also get shifted by 1 digit this way, because it is basically the division operation. That is something what we have done also, right? So 5 to the power of 2 is got shrink to 10 to the power of 2. Okay, that is what we have done. So exponential value got updated to 2 now, and this extra bit, extra whatever the value that we have, that it's something what we updated into the result. So 10 is something got updated, base got updated to 100, exponential got shrink to 2 when we divide it to 2. Now base is actually equals to 100, the exponential value is not equals to odd value, so we will not enter into this results. Okay, we will not enter into the result, but base value, whatever the previous base value we have, we will multiply it again. What happens, this 100 was there, to the power of 2 is something what we have, so again we will multiply it. So what happens, it is like 10,000 is something what the value that we will get. Okay, so we are just directly jumping whatever the values that we have previously, we are just multiplying it 2 times. So this is this particular operation, whatever we are doing, it is basically happening in log of n time. Okay, because we are jumping these values by to the power. Okay, so whatever the new answer that we got, if again we have some values here, if instead of 5, if it is going to be big number, so we keep on doing it, so the base values keep on getting incremented based on previous values. Okay, so it is not like we are getting first index, then second, third, fourth. This once we got this first and two, this is something got multiplied with next two. Okay, directly. That is how the jumping happening right over here. So this way we are actually reducing the complexity from n to log of n time. Okay, now the base is actually this one, and the exponential value is, again, if we divide 2 by 2, this value is basically equals to 1. So again, this value is exponential. Whatever the exponential value that we got, ultimately it will reach to 1 only. Whatever the value that we have, we will end up reaching to 1. The moment we got 1, what we can do, again, it is actually odd number. So 10 is something what, whatever the value that we have is something what we will multiply. Okay, that is what we have done, right? Result into the base value. So in the previously, result was actually having 10. Okay, result will never get updated until unless we reach to even position. Okay, and whatever the base value that we have, it should be 10,000. Okay, the answer is going to be 10 to the power of 5. Again, I mean, I'm just representing it. Okay, so yes, now exponential, again, when we divide it with 2, exponential is actually 0, base value will get updated, but doesn't matter for us. Once the exponential value is actually equals to 0, we will break out of this loop. Okay, this way we will be reducing the time complexity to log of n instead of log n. Okay, so instead of big O of n, we are using this I mean this power arithmetic, whatever the power that we are trying to keep on reducing. That way we will be making the complexity to big O of n log n. Okay. Now this also and this also will get solved with the help of this functionality. Okay, the moment this is done, the result is basically ultimately m is something what we are multiplying. This power is also this whatever the result that we got, we will multiply. Ultimately both these values should get multiplied with nck, whatever the answer that we got from the factorial. Okay, that is the result we are returning at the end. So yes, that's all from this particular video, and I hope you guys got all the doubts cleared. If still not, let me know. I'll try my best to explain you in the comments right now. Okay, thanks for watching this video. Bye bye.